This is a short video that summarizes and clarifies a lot of information in terms of how it is that we use the theoretical sampling distribution to evaluate our F ratio. So what I've drawn here is the curve for the theoretical sampling distribution of F. Just a few notes on this curve. The horizontal axis is F ranging from 0 to infinity, and the vertical axis is either frequency or probability starting at 0 and ranging to, if it's frequency, it ranges to infinity. If it's probability, it ranges to 1. All right, so how is it that we use this to evaluate our F ratio? Well, the first thing we do after we draw the curve is we are going to find our critical F using the table of critical F values. And remember, the rules for doing that is we look up the degrees of freedom for the numerator and denominator of the F ratio. And if that sounds confusing, when you pull the critical F table, just look carefully at the labels for the columns and for the rows, because it usually is pretty clear in terms of telling you how it is that you use those degrees of freedom. So once we find the critical F, we're going to plot it on the chart like this. We're just going to draw a line sort of towards the end of the chart. You definitely want to divide the chart, so don't just put a little tick mark down here. Draw a line that really fully divides the chart into the right and the left. All right, so once you found your critical F, then you're going to plot your observed F on the chart. The observed F is the number that you calculated. It's the number that's going to be in your ANOVA summary table. So you're going to put your critical F on the chart first, and then you're going to put your observed F on the chart wherever it falls. So sometimes your observed F is going to be bigger than the critical F, and sometimes it's going to be smaller. Okay, but first do the critical F, right? So first do the critical F, and then do your observed F. If your observed F falls to the right, you reject your null hypothesis. Right, reject. All right, here's a good memory device. Right, reject. So if your observed F falls to the right, you're going to reject the null hypothesis. What does that mean? It means there is a treatment effect, the means are not equal, and the independent variable affects the dependent variable. If your observed F falls to the left, you're going to do exactly the opposite. You're going to fail to reject, you're going to conclude that there's no treatment effect, you're going to conclude the means are equal, and you're going to conclude that the independent variable, whatever it happens to be, does not affect the dependent variable. All right, so right is reject, left is fail to reject. The other thing that I put on here are these p-values, because I find that this is another point of confusion for students. When you're doing the journal format, you're going to, you put your F ratio, you put your degrees of freedom, you put your observed F, and then you have to put something referring to p after the comma. When you reject, what you put after the comma is p is less than or equal to 0.05. And basically what that means is that your chance of error, is a very specific type of error, but your chance of error is less than 5%. If you fail to reject, when you're writing your journal format, it's p greater than 0.05. And notice where the equal sign is. The equal goes with the reject, not the fail to reject. So it's p less than or equal to 0.05, p greater than 0.05. All right, so critical value goes on the chart, then the observed value. If the observed F is over here, it's reject and all the stuff that comes along with it, right, reject. And if your observed F is lower than your critical F and it falls over here, it's fail to reject and all the stuff that comes along with it. For those of you that are not visual learners, for those of you that find this chart to be confusing, I offer you another alternative, which is going to give you the same information that you're getting in this chart in a short statement. It's something called the decision rule. And here is the decision rule. If your observed F is greater than or equal to your critical F, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Whether you're a visual learner or not, I definitely encourage all of you to write down the decision rule, because you will find as we move through all of our different inferential analysis, this decision rule is basically the same for all of them. In every inferential analysis we do in this class, we're going to calculate some sort of observed statistic, and we're going to find some sort of critical statistic, and the relationship between these is pretty much always the same. If the observed is greater than or equal to the critical, we reject. Otherwise, we fail to reject.